Hello, Haman. How are you? Okay, welcome to another session of Dynamics. I hope you're doing good. We are starting kinetics of rigid motion or rigid body motion. Now, summation of forces is equal to mass multiplied by acceleration, and summation of moment about the center of mass or center of gravity is equal to moment of inertia about the center of mass of the object multiplied by the alpha, that is the angular acceleration. These are the two formulas that we will be using a lot. Now, please do note that when it's a completely translational motion, then alpha is 0, and summation of moment about the center of mass will give me Ig multiplied by 0. Summation of moment about any other point A will give me Ia alpha. Now, you can observe a little difference here, that when you are summing the moments about any other point, the subscript changes for both the fellows. Now, you need to understand that you have to be a little careful, because Ia, you have to be careful because now Ia alpha is equal to Ig alpha plus parallel axis theorem term, that is MAGD, where D is the distance from the center of mass of the object to the point where you are summing the moments. Now, I know that many of you are wondering when we will use this and when we will use this. It depends on the kind of the problem. Many times using this will be convenient. Otherwise, you might want to use this. We will solve a problem today and we will be using both the methodologies. Please understand that when there is a rotational motion, then alpha is not equal to 0. And a general motion in any case is a combination of translation plus rotation. So a general motion, you do know that a tire or a wheel that is just going in a particular direction, it's a perfect example of a general motion where the object has an alpha and object also has a translational motion to it. Now, before we start our today's example, there are 5 ways of getting a moment of inertia about the center of mass. Either it will be given to you, or you have to look it up to the tables. Tables might have the value, or you can calculate using your previous methodologies that have been taught to you, or you get it from this formula Ig equal to kg square m, where kg is the radius of gyration and m is the mass of the object. Now, kg, the radius of gyration, will either be provided to you, or you can find it from the literature. This formula, this radius of gyration is actually is more like a hypothetical construct where you assume that, let's say if this is a wheel and somebody gives me, let's say, the kg, the radius of gyration for this object, then what essentially they do is they say that what if the whole mass is concentrated about one point, I mean about one area only, and then they provide us with kg, and then we use this formula. So this radius of gyration is more like a hypothetical construct for our own convenience. Fifth possibility is that you don't even need this moment of inertia in your problem. So probably that's why they never even give it to you. So anyways, let me ask questions from Haman and Daniel. Everything is fine till now, right? No, I still cannot hear you, Haman, for some reason. Oh, probably something is wrong with your mic. Okay. Okay, Haman, I think sent a message. No, Daniel. Hojam, could you quickly run through it again? Yeah. What I'm saying is that today we are talking about the kinetics of rigid body motion. We are starting it. We will be using summation of forces equal to mass multiplied by acceleration, and summation of moment about center of mass or center of gravity, if you want to call it, is equal to Ig alpha. Ig is the moment of inertia of the object about the center of mass, or if you want to call it as center of gravity. Now, for a translation problem, alpha angular acceleration is 0. For a rotation problem, alpha is not equal to 0. A general motion is actually a combination of both translation and rotation, and a wheel that is rotating but it is moving in a particular direction is a perfect example of a general motion where the wheel also has rotation and it is also translating. I said that we will be using summation of moment about the center of mass equal to Ig alpha. If alpha is 0, this term will vanish. I also said that when I have to, in some problems, I might want to use summation of moments about some other point A. And when I do not do the summation of moments about center of mass, I take the summation of moments about any other point, then I will have to use this formula Ia alpha. You can see the subscripts are same. Now Ia alpha equal to Ig alpha plus another term that appears because of parallel axis theorem, and d is the distance from the center of mass of the object right to the point where you are summing the moments about. This is what I told you. And when your alpha is not equal to 0, you again can write these. By the way, I'm saving my time. You can write summation of moment about g equal to Ig alpha. This time do not remove the alpha. Then also write that we can do summation of moment about A equal to Ia alpha equal to Ig alpha plus mag d. And here again alpha is 0. Here again for this particular case alpha is 0. But you can see that when you're summing the moments about A, you still get this term. When alpha is not equal to 0, then of course these alphas will not be 0. You can write these two equations again. Daniel, did I repeat it, or do you want me to repeat this chunk? Or should I continue? Chat message from Daniel. Oh, okay. I will repeat it. So in a problem statement, you might also need Ig, moment of inertia about center of mass. There are 5 possibilities. Either it is given to you, game over. You have to look it up in the tables. You have to calculate using previous techniques. You have to get it from the formula Ig equal to kg square m, or you can call it as mass multiplied by kg square, where kg is the radius of gyration. It's a hypothetical construct in which what you say is that, let's say if this is a wheel and you want to find the moment of inertia about center of mass, then kg is given to me by assuming that the whole mass is actually concentrated about one line or one one portion only, and then they calculate the kg value, radius of gyration for a particular object, and they provide it to us in a problem statement. So if I give you a kg value for a certain object, you don't ask me how to calculate the moment of inertia. What do? You just do Ig equal to m multiplied by kg square, because I give you the value of kg, which is a hypothetical construct that we have come up with for our own convenience. And fifth is we just don't need it. That's why they did not mention the value. Now, let's say I have this rigid body motion. This is in rotation. Now, summation of forces is equal to m multiplied by ag. You can get two equations for a two-dimensional problem from here, summation of forces in the x direction and y direction. Similarly, you can have, because this is in two dimensions, because this object is going like this. I hope our online students can see me using camera. You can see me, right? So the object is rotating in this plane only, right? It's just rotating 10, 10, 10, 10 like this. Since it is rotating like this, we just need summation of moment about a equal to ia alpha, and these are my equations that I can come up with for my kinetics. As for the kinematics, we have gone through this, right, in our initial part of the semester. You can find the acceleration at point G. This point is my point G. You can see the center of mass is little towards downwards, because this object has more mass in the lower direction, lower portion. So you can use this formula, or for velocity you can use this formula. So acceleration has two components, tangential and normal, and velocity has a tangential component only, of course. Now, of course, this is a very simple problem. This problem is not like the object is rotating about its axis and it's also rotating about, are you following me? So it's not like it's rotating like this and then it's coming like this. This would be like two rotations, one rotation about its own axis, one rotation about this point A. We are not talking about that complicated motion. If you are talking about that complicated motion, of course, then you will have another equation for summation of moment, probably about its own axis, let's say. But my point is, this is a very simple problem for now. If we have, let's say, moments about three different axes, you will have three equations from this. Are you getting my point? Summation of moment, let's say, about x-axis is equal to I subscript x, then alpha about that x-axis, the summation of moment about y-axis equal to I subscript y multiplied by alpha angular rotation that is happening about y-axis. Same story for z. And same here, if the motion was in three dimensions, summation of forces in x, y, z, whatever. And we can have different coordinate system for our own convenience. So this is a simple problem, rigid body motion kinetics. You have to do it now along with me, everyone. Okay, let me ask our online students. I quickly change the slide. Haman, Daniel, Ege Chan, Muhammad Al Khatabi. Should I go back? Any comments? Or should I start solving the rigid kinetics problem? No? Yes? Okay. You can solve this problem along with me. Now, take me through all the steps, everyone. Number one, what should I do? The questions, and by the way, in the last class, if you remember, I did end the class by asking that question. I'm not even sure whether you remember that we were pulling via string. There was this giant wheel and there were four masses that were attached, and the four masses were going like this. I asked this question, why did we take into account only four masses? Why not the mass of the pulley? Because the mass of the pulley was apparently negligible. That's why in that question, only four masses come into the picture in the equations. Anyways, now that we have understood that, first part is that the question says that there is a mass of 20 kilograms for this rod, and there is a pin joint. You can see the pin joint there, right? At point A. What will happen is that there is somebody who is applying a moment of 60 Newton meter. So you are applying a moment of 60 Newton meter. So this object will tend to rotate, right? So apparently the question says that you have to find angular acceleration and the forces exerted on the pin joint. Now what you have to understand is that this is not a strength of materials class, right, anymore. Strength of materials is very statics based, right? Those problems are static. This is not a static problem. This is a dynamic problem. So you cannot just say, well, the reaction in the x direction is zero. No, it's not zero. It cannot be zero because when the object is rotating like this, there would be a normal acceleration component as well. So the first thing first, in an exam setting, you draw a free body diagram. I have to come up with my coordinate system. I think normal tangential are perfect. Normal is towards the center of rotation. Tangential is I always put my tangential towards the motion. So I'm not even sure why did I break my own I did not break my own method. This is towards the center of rotation and this is towards the motion, like in the direction of omega. You don't need to get confused. Then why did you put 80 in the upward direction? Well, that's just a reaction. I'm saying that in the tangential direction, 180 degree to it or whatever, I am calling the force as 80. If you don't like it, you can name it as AY, but I think Y will not make any sense because we are using NNT. Or probably you can put a negative 80 if you don't like 80. Okay, after drawing, and what exactly appears in the free body diagram, the reaction at the pin joint, the weight, you remove all the supports, you put all the external forces, so and moments. So I think I made a mistake here. I am also supposed to put a moment here. Everyone understand this, right? The mistake. Now, everything is in my free body diagram. The coordinate system, I think, is separate. You don't confuse it with this one. After you draw a free body diagram, it makes sense to make a kinetics diagram. Look at here, KD, kinetics diagram. A kinetics diagram has all the necessary accelerations. So my alpha is in this direction. My AG and AGT are in this direction. I did not put omega because kinetics diagram has accelerations, because at the end of the day, they will show up in the form of MA or I alpha in my equations. So you do understand this, that kinetics diagram will also be helpful for me. Now you help me. What should I do? Let's ask our online students. From here onwards, it will be very interesting. Haman, Daniel, Ege, Muhammad Al-Khatabi. Who will answer? What will be the first step in order to tackle this problem? Or Umut can answer, or Isra, or, and your name is? Sini? Sini. Okay, Sini. Sini will answer. Who will answer? No? Okay, I'm sure everybody, yes, we have a chat message from Find IG. Yeah, Daniel is also right that we should find. Yeah, I actually agree with him and I actually agree with you. But let us first write the basic equations, right? So summation of forces in the normal directions is MAN. And I will have minus AN. Then I will have, apparently, how many understand? The normal acceleration is towards the center. So I will have minus, I suppose, M AG N. So it will be equal to 0 minus AN minus. Now you can write it as V square over R. V square over R or rho, whatever, equal to 0. And minus AN minus MV is R omega, R square omega square over rho. equal to 0. And I get a very beautiful answer for my normal force. So normal force comes out to be minus An equal to mass is 20 kilogram. The radius is from the center of gravity, it will be 1.5. Yes, no, 1.5. V is r omega. So I'm not even sure why am I using different nomenclature. I should be a little careful. R will cancel with the power 2. And then I will have multiply by omega, that is 5 power 2 divided by 1 point. Oh, nahi, काफी हो गया. I think it's enough. 20 into 1.5, because r will cancel with the power 2, multiply by 5 square. So An comes out to be minus, use a calculator and tell me. No, it's not clear, Umut? It's clear? Sorry? You did not understand? So what I'm saying is that the summation of forces in the normal direction is equal to mass multiplied by normal acceleration. So this is your normal direction, right? So I'm summing the forces in this direction only. So now, what are the forces in this direction? I have An in the negative direction, so minus An. My normal force is also directed towards this, because normal is directed inwards and radial is directed outward. Okay, so An comes out to be, Daniel or Haman probably can help me. I think 750. You can double check. I do have to double check my notes, because I think my notes does not talk about whether it is in this direction, but I think negative makes sense, no? So answer is coming out to be negative. This means this should be towards right. I think that's the problem. So probably when I was making the reaction, I should have been a little more careful. Yeah. So we should have selected towards right. So this is also telling us that the reaction should be in this direction. Okay, now what about the last, the second part? We have to do summation of forces in the tangential direction equal to MAT. So I will have, let's say, downward is negative, then minus W, then plus AT equal to MAT. And instead of AT, I think I should be careful here. I should put AGT. So minus mg plus AT equal to, mass is, what is mass? 20 kilograms multiplied by AGT. Now, what is the value of AG? It is alpha multiplied by R. That is R alpha. So here I'm not using any vectors. I do have an idea that tangential will be, tangential acceleration of course is in tangential direction, so I'm not using unit vectors. I do note that this object has, we have to find the alpha. So my guess is that probably this object is accelerating in this direction, or probably I don't need to take, okay, I will just follow what is in my notes right now. So let's say positive direction I am taking as downwards. You can do it that way as well. Positive is downwards. So W minus AT equal to. In this way, what I am assuming is that the object has a linear component of acceleration downwards. In this way, we are also assuming that the object has a probably a clockwise alpha, I think, right? Because if my positive is downwards, you can see positive is downwards, and I have a positive fellow here and a positive MAGT, means I am assuming that my tangential acceleration is positive downward. You can see from here, and that's why I put a positive here and a positive here, because we don't play with this. Usually, we don't play with the sign of the right hand side in the summation of forces equal to MA or summation of moment equal to I alpha. We are more concerned towards the left chunk, right? So that's why it's important that I am a little careful. Positive is downwards. That's why I corrected myself. Is this part clear to our online students who are not responding? Is this clear to Haman, Daniel, Ege Chan, and Muhammad Al Khatabi? Okay, good. It's clear to Daniel. Okay, thank you. Now, all you have to do is do number crunching. So you do a 20 multiplied by 9.81 minus 80 equal to the R is 1.5, 20 multiplied by 1.5 multiplied by alpha. Great. So now the last piece of the puzzle, let's see what exactly I get. The problem is that from here, you are getting the normal reaction, but for finding the reaction in the tangential direction, I mean this direction, 80, you also need, oh, I think we have everything. No, we don't have alpha. So we cannot proceed in this problem because now I have just one equation with two unknowns. From this equation, I already get the normal reaction. So I have to use the next equation, that is what one of the students just told us in the beginning. So I will do summation of moment about the center of mass equal to Ig alpha. With, let's say, I say clockwise as positive. Because I am saying this because the moment is applied like this, so I have a very intuitive feel that clockwise we will have alpha. So makes sense that I am just assuming clockwise as positive, so that my answer comes out to be hopefully positive. Now, okay, who was the student who told us find the moment of inertia first? Who said that? Daniel. Daniel said that. So let's use Daniel's strategy. What is Ig? So right now you have to Google it. Google the center of mass for a thin slender rod and tell me what Google tells you. Okay, I actually know it right from the top of my head, but you have to do it in your free time. Open even a Wikipedia page, find the center of mass for a thin slender rod. You will see that Google will tell you that Ig is equal to 1/12 ml square. Does this formula ring any bells? It does, right? You have heard of it. Now all you have to do is do number crunching. The length of this rod is 3, and I have been taking the R as 1.5 because for center of mass we are considering everything, right? The weight X at the center, that's why I had been substituting 1.5 at quite a few locations here. But L length is 3, so I will substitute 1/12 into 20 into 3 square. So why don't you tell me answer? Okay, chat message from Daniel is 15. I completely agree with you. It comes out to be 15 kilogram meter square. This is my value of Ig. So now I will say that It is okay, so follow me. Clockwise moment MA is applied. So I will say MA, keep focusing on the left hand side. Moment about, and that's it. So there will be one more. I am applying the moment about the center of mass. So when I am talking about the moment about the center of mass, then MA will appear, right? Because at the end of the day, the moment is being applied on the structure. So MA appears. What else appears about center of mass moment? You can look at here. Minus 80 into 1.5 appears. No, positive, because clockwise is positive. So positive 80 into 1.5 appears. No? Yes? Plus 80 into 1.5 appears. AN passes through the center of mass, so that's not a problem for me. Equal to 80 multiplied by R, if you want to call it, equal to IG alpha. Is this clear? I just went at sonic speeds. Okay. Is it clear to Isra? Everyone, I can repeat that if you want. My point is that we are summing the moments about the center of mass. So weight passes through it, so no problem. We don't worry about the weight. We will just say MA and then there is an 80 multiplied by this distance. So MA plus 1.5 into 80 appears. And then I have this equation as my equation, let's say 3. And this is my equation number 2, this one. Equation number 2. So why don't we solve it together? So let's say MA plus 80 into 1.5 equal to IG alpha, and let me write the equation 2 as 20 into 9.81 minus 80 equal to 20 into 1.5 into alpha. Solve it and give me the value of alpha. And also please tell me the value of 80. Alpha comes out to be 5.9 and 80 comes out to be 90 Newton. Why don't you double check?
First, why didn't we multiply the first part with R 1.5?
We did 80 into 1.5. This one?
Yes.
That's a moment, not a mass. That's moment. Summation of this capital MA is the moment that is given to me. Newton meter. 60 Newton meter. So 60 Newton meter plus force multiplied by distance Newton meter equal to IG alpha. Newton meter. This is moment.